Game theory. What is a game? A game consists of a set of players, a set of strategies for each player, a situation where the participants' payoff depend not only on their decision but also in their competitor's decision. This is called strategic interactions. Equilibrium. We assumed that each player is rational to determine the outcome of the game. The interaction of all rational players' strategies results in an outcome that we call equilibrium. In equilibrium, each player is playing the strategy that is a best response to the strategies of the other players. No one has an incentive to change his strategy given the strategy choices of the others. Solution steps. The search for the saddle point of a matrix game can be made in 3 steps. Step 1. Write the minimum entry of each row at the end of that row and write the maximum entry of each column at the end of the column. Step 2. Identify the maximum strategy for player B1, the largest of the row minimum, and the minimax strategy for the player B2, the smallest of the column maximum. Step 3. The game has a saddle point or equilibrium point if the maximum and the minimax are equal to the same number, and that number also appears at the intersection in the matrix. Example 1. Find the best strategy for B1 and B2. Use the following payoff matrix to determine if the game has a saddle point, equilibrium, and what is the value of the game. Here we have 2 players, B1 and B2. B1 has 2 strategies, B1 and B2, and the other players have 2 strategies, Y1 and Y2. If the first player take B1 and the second Y1, the outcomes will be 3. And if the first player take B2 and the other players B2 take Y2 strategy, the outcomes will be 8. To find if the game has a saddle point, we prepare as we mentioned before. Now we will determine the minimum of each row. The first row, the minimum is 2, and the second row, the minimum is 4. And for the column, we will determine the maximum number in the column. For Y1, the maximum is 4, and for Y2, the maximum is 8. Now we will select the maximum strategy for player 1, which 4. We will compare 2 and 4 and select the largest of them. And for player B2, we will select 4, which represents the minimax strategy. We see that the 2 numbers is the same. And also at the intersection in the matrix of maximum and minimax. So the game has saddle point or equilibrium point. The game value is 4. Games with mixed strategies. Example 2. Find the optimal strategies for players B and Q for the matrix game given, and determine if the game has a saddle point and the value of the game. The solution. First step, we compare the two numbers in the first row, 29 and 4, and select the smaller of them, 4. This represents the row minimum. For the second row, 15 and 25, 15 is the smaller number. And for the column, we compare 29 with 15 and select the largest of them, 29. And for the second column, 4 and 25, we will select 25, which represents the column maximum. Now we choose the maximini for the row 15 and the minimax for the column 25. It is not the same numbers, so the game has no saddle point, because the row maximini not equal column minimax. When a game does not possess a saddle point, game theory advises each player to assign a probability distribution over a set of strategies. Games with mixed strategy. We prepare this schedule for the game. First, in each row, we will make the difference between 29 and 4, and the difference between 15 and 25. Also for the column, we will see what the difference between the two numbers, and for the second column, what is the difference between the two numbers. The difference between 29 and 15, 14, 4 and 25, 21, and the difference between 29 and 4 in the first row is 25, and the difference between 15 and 25 is 10. The sum of the two numbers is 35 for column and for rows. Now we replace the numbers. The numbers in the first column, 14, will be in the second column, and the number in the second column will be in the first column, and the number in the first row will be in the second row, and the number in the second row will be in the first row. We will divide 10 times the summation of the two numbers, 10 plus 25, 35, equal 0.286. And divided 25 by 35 equal 0.714. The summation of 2 must be 1. For the column, we divide 21 over 35 equal 0.60, and 14 over 35 equal 0.40. the strategy B1 Q1, the row and the column, the outcomes of the row and the columns for these two strategy 29, and for strategy B1 and Q1 4 and B2 and Q1 15 and B2 Q2 25. Probability of the mixed strategy. For strategy B1 Q1, B1 we will take the probability 0.286 in the first row times Q1, the probability of this strategy 0.60. The strategy B1 Q1 for the first row 0.286 times the strategy Q2 0.40. Strategy B2 Q1 for the row 0.714 times the strategy Q1 0.60. Strategies B2 Q2 we multiply 0.714 times 0.40 the multiply will be for the strategy B1 Q1 0.17, for strategy B1 Q2 0.11, for strategy B2 Q1 0.43, for strategy B2 Q2 0.29. The summation of this mixed strategy equal 1. The value of the mixed strategy, we multiply the probability of the mixed strategy times the payoff. The payoff for the strategy B1 Q1 29 times 0.17 equal 4.93. For strategy B1 Q1, the payoff 4 times 0.11, the probability of these two strategies will equal 0.44. For mixed strategy B2 Q1, the payoff 15 times the probability of them 0.43 will equal 6.45. The strategy B2 Q2 payoff of them 25 times the probability of them 0.29 equal 7.25. The summation of the value of the mixed strategy equal 19.07. This is another type of solution. We can use the payoff matrix A11, A12, A21, A22, which mean A11 means the first row with the first column, A12 the first row with the second column, A21 the second row with first column, A22 the second row with the second column. We will use this payoff matrix with the example. First, we must calculate the D, the divisors, equal A12 minus A21 minus A12 plus A22 equal 29 minus 15 minus 4 plus 25 equal 35. Value of the game equal A11 times A22 minus A12 times 21 over D equal 29 times 25 minus 4 times 15 over 35 equal 19. This is the value of the game. Optimum strategy. For raw players, his strategy B1 and B2. B1 equal A22 minus A21 over D. 25 minus 15 over 35 equal 0.286. B2 equal 1 minus B1. 1 minus 0.286 equal 0.714. For column player Q1 and Q2, Q1 equal A22 minus A12 divided by T equal 25 minus 4 over 35 equal 0.60. 1 minus 60 equal 0.40. It is the same answers as we mentioned before. Example 3. Find the optimum strategy for players B and Q for the matrix game given and determine if the game has a saddle point and the value of the game. We will compare for the first row 18 with 25 and select the minimum of them 18, and for the second row 22. For column we will select the maximum of the column 18 and 30, and for the second column 25. When we compare the row minimum 18 and 22, we will select the maximini 22, and for the column 25 represent the minimax. The two numbers is not the same, so the game has no saddle point. The row maximini not equal column minimax. Now we will begin to see what is the difference between the row, the strategy in the first row 18 and 25. This is mean that the first player take the strategy B1 and the second take Q1 or Q2. The difference between the two strategy is 7. And for the second row 13 and 22, the difference between them is 8. Now we will make replacement 8. The second row will be in the first row and 7 in the first row will be in the second row. For column, we will first make the difference between 18 and 30, which equal 12, 25 and 22, 3, and make the replacement 3 in the second column will be in the third column, and 12 in the first column will be in the second column. 3 divided by 15, the summation of the two number in the first and second column is 15. 3 over 15 equal 0.2. This is the probability of this strategy. 12 over 15 equal 0.8. For the row, 8 over 15 equal 0.53, and 7 over 15 equal 0.47. Strategy B1 Q1, the payoff 18, and the strategy B1 Q1, the payoff is 25. The strategy B2 Q1, the payoff is 30, and strategy B2 Q2, the payoff 22. Probability of the mixed strategy, we will take B1, the probability of B1, the first row is 0.53 times the probability of Q1, 0.2. It will be equal 0.106 for the strategy B1 Q2, the payoff 25, the probability of B1 0.53, and the probability of Q2 0.8 equal 0.424. The strategy B2 Q1, the probability equal 0.47 times 0.2 equal 0.094. The strategy B2 Q2, the probability of this strategy 0.47 times 0.8 equal 0.376. The summation of this mixed strategy should be 1. Now, to calculate the value of the mixed strategy, we multiply the payoff of each two strategy times the probability of this mixed strategy. 18 times 0.106 equal 1.908. And for the second two strategy B2 Q2, the payoff 25 times 0.424 equal 10.6. The strategy B2 Q1, the payoff 30 times the probability of these two strategy 0.094 equal 2.82. The probability of the strategy B2 Q2, the payoff of them 22 times the probability of them 0.376 equal 8.272. The summation of this strategy represents the value of the game equal 23.6. we can use the payoff matrix A11, A12, A21, A22. First, calculate the divisors. D equal 18 minus 30 minus 25 plus 22 equal minus 15. The value of the game, A12 times A22 minus A12 times A21 divided by D. 18 times 22 minus 25 times 30 over minus 15 equal 23.6. The optimal strategy for row player B1 equal A22 minus A21 over D equal 22 minus 30 over minus 15 equal 53.3. B2, strategy B2 equal 1 minus B1 equal 1 minus 53.6 equal 46.7. The column player, the strategy Q1 and Q2, Q1 equal A22 minus A12 over D equal 22 minus 25 over minus 15 equal 0.2. 1 minus 0.2 equal 0.8.